Testing smart contract is one of the high paying skills. Companies like OpenZipping, Hardhat, Truffles are looking for developers who can test the smart contract. Okay, so if you have the right skill about the testing, about the tools, then you can be a great addition to any company and your salary will go amazingly high. Okay, so that's why I have this complete course for all of you, only focus on testing part. Okay, so in this, we're going to learn about that. What are the tools you have to test the smart contract and which one is more better and which one is more industry friendly. Okay, for testing smart contract you have two powerful tools, Hardhat and Truffle, but in this course we're going to use Hardhat for testing the smart contract. And the reason why I have decided to take Hardhat instead of Truffle, because Hardhat is most demandable right now when it's come to testing the smart contract. It's come with a lot of powerful packages which you can utilize to test your smart contract even it to the next level. Okay, you can do the customization, a lot of functionality or features you will find in Hardhat. So that's my personal choice, and that's why I've decided to build the entire testing process in Hardhat. The process is same when it's come to Truffle. Okay, so if you know how to do the testing in Hardhat, you can do the same way in the Truffle. Okay, there is no much difference. Okay, so that's the intro part of this Hardhat course. Let's jump straight away into my code editor and let's start coding and testing the contracts. Here I'm back into Visual Code Studio, so make sure you open that. And this is going to be our ultimate resource. Okay, so we're going to follow the complete documentation of Hardhat, or whatever I'm going to teach you and whatever examples I'm going to pick in this complete tutorial, that's going to be from this documentation. Okay, so you can simply open up the documentation and you can have a look that what are the function we are calling. Okay, so here we have these three methods to install the Hardhat in our computer. So we have npm 7 plus, npm 6 and yarn. Okay, but I'm going to use this npm 7. Okay, so simply copy this and let's come back to the terminal. And now first thing we have to do is we have to initialize the project. Okay, so we'll say npm init. Okay, so we have to initialize our project and you can give whatever name you want. So I'll give this Hardhat. Make sure to give the name in slash, otherwise it will throw an error. Hardhat testing, and hit enter, and I'm going to give my name $2, and that's it. Okay, so this is how we have generated our package.json file. You can find all the details about the project. Okay, so we have the name, subscriptions and script. Okay, all the things we have here. Now let's come here and we have to install a couple of things. Okay, so let's install the npm Hardhat. I'm installing Hardhat as a dev dependency. Okay, so let's install this. Hit enter. Okay, so this will take a little bit time. In my case, I'm just doing fast forward so you guys can see everything's happening fast. Okay, so it will take a little bit time. And here we have successfully initialized Hardhat in our project, and now we have to see this is the version we are using, 2.12.0. okay, so make sure you use this 2 point version for this tutorial. At the time of recording, this is the latest version, so make sure to use the latest one. So we have Hardhat in our project, and now what we can do, let's come here and we're going to initialize Hardhat. Okay, so we'll type npx Hardhat. Okay, hit enter, and this is how it will look. So this is going to be the starting point for Hardhat. Okay, so here you will find three options. First, you can create a JavaScript project which will give you all the folder and file structure and all the basic configuration which is already give you. Okay, and there is another option you have as a TypeScript. So if you want to build a project and do all the testing in TypeScript, you have that option. But here I'm going to show you that how you can start from the beginning. Okay, so that's the very best thing to learn. Okay, because if you get a pre-written code, then it will not make that sense. Okay, so I'm going to select this, the third option. Okay, so make sure you pick this one, create an empty Hardhat config. Okay, so hit enter, and here we have initialize empty Hardhat file in our project. Okay, clear the terminal, and here you can see we have the Hardhat config file. And if we click on this, you can see right now we are using this Solidity 0.8.17 version. So that's the Solidity version we have. Now we have to install a couple of things. Okay, so the first thing we have to install is this Nomic Foundations Hardhat toolbox. Okay, so this one is a very important package which you have to install, because we're going to test and we're going to use a couple of libraries. Okay, so we're going to use this toolbox to do the testing. Okay, like Mocha and Chai library, that's all will come from here. Okay, so we have this Nomic Foundation Hardhat, just let it be installed, and this will take a little bit time. And finally we have installed Nomic Foundation in our project. You can see this is the latest version we have, and let's come here. Everything's looking good. So we have our packages and file, and now let's quickly create the folder and file structure for Hardhat. Okay, so first folder we're going to create is contract. Okay, now we'll create another folder. This will call script. We'll create another folder we'll call test. So these are the three folder we have. Now let's create the file. So we'll call it my test. Okay, so this is going to be my Solidity smart contract we're going to write inside this. Now let's create the file for the script. We'll call deploy.js. That's the deploy script. And now we have to create a test file as well. So test.js. So that's the folder and file structure. Everything's looking good. Let's bring this down and close this one. Now I want you to install one package that's called Nomic Foundation. Okay, so type Nomic Foundation and click on this. I have already installed in my code, so you can see what it provides. So it will generally allow you to provide this. Okay, you can able to find this predefined code. Okay, auto suggestion you will get. So make sure to install this one. Now I'm going to take another file. I'll call it, let's say, note.txt. In that I'm going to give you a couple of notes so you guys can remember like what are the commands we have to run. Okay, so let me type this important notes. Okay, if I make any spelling mistakes, please forgive me for that. Okay, because I'm really bad with the spellings. I'll say Hardhat testing. Okay, and let's come here and I'm going to copy the script. Okay, so this one is the, let's say, installation. Paste here. So this is the command we have to run for installing Hardhat, and we have to write the another package. Okay, so this is the package we have used. Simply copy and paste, because ultimately I'm going to provide you the source code so you guys can take the reference from where I'm getting all this. Okay, so we have the package.json file. Now I want to type all the global commands, all the global option we have available in Hardhat. Okay, which we're going to use while testing the contracts. Okay, so let me give this command called import globals commands. Okay, Hardhat. Okay, so I'll simply copy and paste all the commands here. Okay, it's a huge list. You can see we have configuration, emoji, max memory, network, like all the versions, and here we have downside all these command as well. So for clean we have compile, console, help, node. So we have all these command we're going to use. Okay, explore each one of these. Let's close this one and close this one and come back here in the contract and let's start working on it. Okay, so let's start writing our contract. So you guys all know that we have to follow the general convention in Solidity for writing our smart contracts. So let's provide the SPD license identifier, and it's going to be, let's say, unlicensed. I'm going to take the Solidity version is going to be, let's say, 0.8.9. Okay, so this is the version I'm going to take. Okay, and that's the general convention you have to follow. Now I'm going to do a couple of important imports. So import the Hardhat console. Okay, import, and that's coming from Hardhat as well. Okay, Hardhat/console.log. Okay, so this is our Hardhat console. So if you want to see any value in our smart contract in our terminal, so we can use this Hardhat console to check the value. Okay, and that's a really powerful tool because in that way you can easily able to monitor that what value you are getting in which function. Okay, so that's a really powerful tool. Okay, so that's the internal import we have, and now we have to write our contract. So I'm going to take a contract, and let's say I'm going to call my contract my test. Okay, so this is the name I have given to my contract, and I'm going to take a couple of variables. So the first variable I will take unt 256 public, and this will call unlock time. And this contract I have taken for the document variable. I will take another variable address by payable, and we'll say public and owner. So these are the two state variable we have, and we're going to take an event, and this will call withdraw, because ultimately we're going to transfer funds, so we have to take the event so we can keep the track. And that we're going to take this, let's say, unt 256 the amount, and we have to pass the time as well. So unit when. So these are the two data we're going to pass inside the withdraw event. Okay, the amount and when the event was took place. Okay, so that's the two data we have to pass. So that's the event we have. Now let's come down, and now we're going to build the constructor, and in that we have to pass the exactly the time. Okay, so this contract will work like this. Okay, so just imagine that you have deploy a contract. Okay, and that contract contain any value. It has, suppose, 100 ether or 50 ether, and you want that the owner of the contract can only withdraw that amount after a particular period. Okay, you have found this kind of logic, this kind of smart contract in the decentralized space where where the exchange allow you to submit your token, and you have to lock your token for a couple of time, and if you do that they will give you a couple of reward in back. Okay, so this kind of contract we're going to build. Okay, so we're going to pass the timestamp. Okay, so how long we want to lock the amount in the contract. Okay, so we'll say unlock time. That's the thing we have to pass, and ultimately at the time of deployment we're going to add ether into this contract. So we have to make it public. So we'll make it public, and here we're going to do the update. Okay, so first we have to check the condition. Okay, and here we have to check for a condition. So first condition we have is block.timestamp. Okay, at the time of deploying we have to take the time, and that time, this lock time should be in future. Okay, should be in future. So what we are doing when we are deploying the contract, we are taking at that time and we are selling that whatever the user timing is providing, that should be less. Okay, the block timestamp should be less than the user providing. Okay, so that's the entire logic, and we go to pass our error message. We'll say something like your unlock time should be in future. Okay, that's the message we want to pass. So that's the one check, and we have to do the, let's say, then once we done the check we have to update that. So we'll say unlock time is going to be unlock time, and we have to set the honor to, we have to make it payable message dot sender. Hope things are getting clear to all of you. Very simple logic. We are taking the time, that what time the owner can withdraw the money, and then it's providing the right time, then we are updating the entire data. Okay, so that's the our constructor. And now we have to create a function which allow us to withdraw the fund. Okay, so we'll say withdraw, and we'll public, so public, and here we're going to check that condition. So we'll say that, let's say block timestamp. Okay, so we have to check the timestamp, that the time is over or not. Okay, so if the time is less or equal to, then we only allow the owner to withdraw the fund. Okay, otherwise we have to throw this error message. So wait till the time period completed. Okay, so that's the first check, and now we have to do the other checks, that whoever is calling the function, it should be the owner. Okay, so message.sender equal to owner. If it's not that, if someone else try to call it, we have to throw this message. That's simple logic. Okay, you can do a hell lot of things. Okay, you can create a modifier and you can add as a guard class, but I'm just trying to focus in a more simple term because we are focusing more on smart contract. Okay, and here we're going to update the entire things. So we'll take this event and withdraw, and in that we're going to pass the add the amount. So we have this address, this we are referring to the contract, and we have the balance. Okay, balance, and here we are passing the timestamp. Simple block dot timestamp. That's what the data we need in our event, and now we are transferring the fund to the owner. Okay, so address, this, balance. Simple logic. Hope this makes sense to all of you guys. So that's the entire function we have here. You can see these are the state variable, these are the withdraw functions, sorry, constructor, these are the withdraw function. Looking, everything is good. Now let's come here and close this one, and now let's come back to the deploy, and here we're going to write the code for the deploy script. As you can see, our deploy script is completely empty. Okay, so we're going to write it from scratch. Okay, so here what we're going to do is we're going to simply take a variable ref, and it's coming from Hardhat. Okay, so it's required Hardhat. Now we have to take this console.log. So let me show you that what value exactly we have into this. Okay, so let's open it and let's try to run this deploy script. Okay, so this is the script we have to run if we want to run the deploy script. Okay, so we have npx hardhat to run. Inside the script folder we have this deploy folder.js. Okay, so make sure you have this exact directory, npx hardhat run script deploy.js, and hit enter. Okay, we have inside this, hit enter, and here you can see we got back all these objects. Okay, and that's what we have inside this. It's, this list is huge. You can see the Solidity, network, path, and we have all these values times something. As you can see, we have using Mocha library for, so we have that as well. This is the name, all the functionality we have into this. Okay, and that's coming from Hardhat. Okay, so we're going to utilize couple of properties to test our smart contract. Okay, so now here we are back into the deploy.js, and I'm going to simply comment this out. I'm not removing this comment because I want you guys that after these codes you guys should go through one more time and try to check each and every value which we have in each of this function. Okay, so let's comment this out, and now let's just bring it. I'll take a async function. Okay, and that's a very important part. Okay, here you have to use the async function because we are going to deal with the promises, and we're going to provide a name. I'll say main. So we have this, and now let's come here, let's bring this down, and we'll take this const current time in timestamp in second. Okay, you will see why I'm doing this. Just follow along with me. So here what I will do, I will simply use this math property. Okay, so it's a JavaScript random, and in that we're going to take the current timestamp. Okay, current time, and I'm going to multiply with the 1000, so we can easily able to convert that time into a second. Okay, so that's what we are doing. We are taking the current time in second. Okay, and now what I will do, I'll simply take another variable. I will say 1 year in. So here what I'm doing, that I'm allowing the owner to withdraw the fund after 1 year. So whenever he deploy the contract at that point of time, and after the 1 year he can able to withdraw the fund. Okay, so that's what I'm doing. So 1 year in second, and it's very easy to get in second. So we'll have this 365 days. We're going to multiply with 24, then we have to multiply with 60, then 60, and then 60. Okay, this will give the data in second. Okay, and now we'll take another variable. We'll say unlock time, and we're going to take the previous time, means the time we are deploying the contract, and we're going to add the future time. Okay, so we'll get the exact time which we have to pass into the contract. Okay, we'll simply pass that. Hope these things are making sense to all of you. Now let me call this functions, and it's a async function, so we have to catch an error. So we'll say console.log error, and we have to stop the process. Okay, so once the deployment process get over, we have to stop that. So we have to provide that exit code. And again, I'm telling you all of this from the documentation. So if anything confuses, make sure after the tutorial you should refer one more time. So that's the calling function here we have. Things are looking good. Now let me console log out all the values, and let me show you what we get. Okay, so we have this 1 year in second, we have this unlock time. So I will simply deploy this contract. Let's deploy this, and here you can see we got the current timestamp, then the future time, and when we are adding those time, and we are getting the final time, lock time. Okay, so hope these things are making sense. Okay, and the reason why we are passing the data, the timestamp into second, because you know that when you do the transaction on the blockchain, the block transaction timestamps come in the form of second. Okay, so we have to convert. You can't send the minute or days data. Okay, so that's the thing you have to keep in mind. So it's looking good. Now let's come here and let's continue ahead. So here what I'm going to do, I'm take a, let's say another variable, and I call lock amount. So we have to specify that what amount we want to pass into the constructor. Okay, because our constructor will have some money, and that's why we are building up this contract. Okay, so here what we're going to do, we're going to call this href ether utils, and we're going to convert that to a parse ether. Okay, means 1 ether. Okay, and again I'm getting this variable from the ethers.js. So if you haven't watched the complete playlist, complete video I have made on ether.js, and make sure to follow. I will link in the I button in the description, so you guys can have a complete understanding. So that's the lock amount we have, and now let's copy and let's try to check that what we get exactly. And here you can see, here we get an error, cannot read properties of undefined. Okay, why it's so, why it's happening? So let's come here and let's me try to comment this and bring it back and remove this part only. Let's try to see what data we get. Let's run this one, and again I'm getting the same notification, same error. Why? Okay, let's come here and let me remove this part as well. So let's run this one, and this time actually our ether.js is not there. It actually says undefined. So we have some problem. We are not getting that ether package in our project. So why it's so? And I know the problem. We have to go back to the configuration, and here we have to explicitly define the package. Okay, so let's say required, and we have to define this nomic foundation, because in this we have all the packages. Okay, so we have to define this here to use that package. Okay, so you guys can understand that how important this tool. So now we can save it. Let's come back and let's try to rerun this. Okay, let's open this one and bring this back and open up your terminal, clear your terminal, and let's run the script. So let's clear it, run the script, and just wait. And here you can see we got all these details, and here you can see down below we are getting this value. Okay, big number is this. Okay, so we are getting the data. So let's come here, let's comment this out, and let's try to rerun this one more time. Okay, so let's have a look, clear the terminal, and redeploy the contract. Here you can see we got this big number, means everything's working fine. Our package is working fine. Hope these things are making sense to all of you guys. And let's come here, comment this part, and now we can. So make sure you have to do this configuration in your Hardhat config file to use any packages of Hardhat. Okay, so that's what we are doing here, and everything's looking fine. Let's come back here. And here we're going to write the script for deploying the contract. Okay, again, I'm not removing this comment so you guys can have a reference. So let's bring this down and let's remove it. Come here and let's take another variable. We'll call it my test. Okay, so now we're going to actually interact with the smart contract. Okay, so we're going to say, let's say, await. We're going to take our href and ether js. We're going to get contract factory, and in that we have to pass the name of our contract. Okay, so I'll call it my test. Okay, and that's the general convention, that you give the name of the variable and the smart contract name same. Okay, so this is a very general convention you will find in all of the smart contract deploying code. Okay, so everything is looking good. If you come here, that's the same name we have given here. Simply copy and try to paste here. Okay, now we'll take another variable and this will call my test await, and here we're going to call this my test deployed, and in that we have to pass the data. Okay, so our constructor need an amount and a timestamp. Okay, so here I have already have the log time that, so I already have the log time, and here I'm going to take this and I will send, let's say, amount. Okay, so we have 1 ether. Okay, and that's what we are sending. So that's the setup for the contract, and now we're going to deploy it. So await my test dot deploy, then we're going to call it. Okay, and now I want to simply console log out the address of the contract so we can later use it. Okay, so contract 1 ether and the address we have inside this my test is the complete instant of the contract, and from there we can easily able to access this address. Okay, so that's looking fine. Okay, and let's come here, let's simply clear the terminal and deploy that one more time. And here we can see that we got an error. It says that HH700 artifact from contract my test not found. Why so? Okay, that's something weird. So I was stuck for a half an hour to find out that what's the problem we have in the code, and I made a very silly mistake because Hardhat is a very sensitive in terms of folder names. Okay, so here what I have done, I have provided my contract folder name is only contract, but it's contracts. Okay, so I have to rename that. Okay, like type S. You can see sometimes you make such a silly mistake in your folder and you waste a couple of time. It's not actually waste, it's part of learning. Okay, so you make sure you have to rewrite the contract spelling. Okay, CONTRACTS contracts, and now it will work. Okay, and now if we deploy the contract and hit enter, and boom, you can see we have successfully compiled the code, and here we got the address of the contract. Okay, things are looking fine, and now we can check. Here you can see we got the artifact, and in that we have our API. So that looks fine. And here you can see we have all the details about the contract, whatever we have written. So it has the name, it has the folder source, that where this file locates exactly. You can see the source file is exactly this. Okay, contract. So make sure you should always follow the recommended name. Okay, so this is the folder location we have, and here we have defined all the variables. You can see all the variables we have defined, and constructor, its payable, and all the data. You can able to find whatever you have defined in the contract, and this is the bytecode. You can easily able to decode this and have all the contract. Okay, so that looks pretty good, that looks pretty impressive, and I want to show you one more thing. Okay, so let's come here and simply just stop this server running, and let's type simply come here and deploy this contract and final time, and here you can see, just wait, and finally we have deployed the contract and everything's looking good. Simply copy that. I want to show you one more thing. I want to show you the complete instance we get back when we deploy the contract. Okay, so let's come here, we'll say console, and I will take this my test. Okay, and from here you can easily able to find all the data about the contract. Okay, all the instances, and that's very important because sometimes what happened that you have to check the events. Okay, so whatever event you have defined in the contract at the time of deployment or at the time of function calling, you can able to check. Right now you can see that we are not calling any event at the time of deployment. Okay, so in that scenario we'll have an empty. So let's hit that, and here you can see deploy the contract, and here you can see we get all the data, all the instance of the contract. Okay, so just have a look. You can see all the function we have defined. So we have a variable, state variable in our smart contract honor, and that's a public one. So that's why you can see this function. So whenever you use public keyword in your smart contract, you will automatically get a getter function for that. So we have this unlock time. You can see it's a function we can easily able to call. We have a withdraw function, and here we have the error events. You can see we have this event, withdraw event. Okay, so this is the event we have. So all the data we have defined in the smart contract, that all you can able to find in the instant, and you can utilize that. Okay, actually that the data we utilize to fetch the data and interact with the front end. Okay, so that's the very important thing. I must tell you that you guys should open and check all the values, okay, and try to test everything. So that's what we have. Simply comment this out, and that's the entire thing for the deployment part of the contract. Okay, so that's the basic thing. And again, I'm not coming up with this example because it's in the documentations, and whatever I'm going to tell you in this video, that's all going to be on the base of the documentation. Okay, so that's the one of the best resource you can have to learn, and that from there I'm telling you all this. Okay, so that's the deploy script. That's the entire deploy script. Let's cut this on and let's come back to the start of the show. Okay, because we have to test the contract. Okay, so let's come back to this test, and now we're going to do the most important thing. We have the contract, we have the deploy script, but we have to write the functionality to test the contract. Okay, so here what I'm going to do, I'm going to take a variable I'll call time and load fixer. Okay, and this will come from, let's say it will come from required same nomic foundation Hardhat. Okay, Hardhat network helper. Okay, so from this I'm getting this two function. First one is the time and the second one is loader fixture. So these are the two things we are getting. Let me console log out that what we get exactly in this. So you can see time and loader fixture. If I open this, so here I have to run this command npx hardhat test. Okay, so this is the command you have to run, hardhat test, and wait. And here you can see we got this entire function. So you can see from the time we are getting this duration in millisecond, second, times, hour, date, week, and years, and we have all these properties as well. Said advanced block to increase to latest block. Okay, so we are getting all this data from this time. Okay, and here we have this load fixture. Okay, load fixture function, and I'll talk to you what the load fixture is. Okay, so just wait. Okay, so we have all this data that we can easily able to access. So if I bring this one, if I comment this one, and I want to show you one more thing. So let's bring down console.log and time date. So I'll get an undefined. Okay, so if I run this, I'll get an undefined. Okay, if I hit enter, you can see I'll get nothing, undefined, because in that we have to pass data and we are not passing any data. That's why we are getting this undefined. Okay, so that's the undefined. Let's comment this out, and now we're going to import a couple of more things. So let's come here and we want to import this any value, because when we deploy the contract we have to assign this one. Okay, so this is coming from required and it's coming for nomic foundation and hell hardhat, and this is the chai marcher. Okay, so make sure to type the exact spelling and with agar. Okay, so this is the exact directory you have to provide to use this function. Okay, so simply call this one, and if I simply console log out and try to have an access of this value, let me show you what you will get. So you will get a function. Okay, say this is the function we have access. Okay, and that's what we're going to utilize later when we do the transfer of the funds. Okay, hope these things are making sense to all of you. You can easily able to find each and every value in each and every imports we are doing. Okay, now we have to import one more thing. So we have to import the exact expect, and that's coming from chai. Okay, this expect does, it will allow us to do the comparison. So just imagine that we have defined any value in our contract, for example 100. Okay, and we're going to define the same value here in the deploy script, and we're going to compare both of the value. If both of the value is exactly the same, then our contract is fine. But if there is a problem in the contract value or in the deploy script value, then there is a problem. Okay, so this will allow us to do the comparison. Okay, we'll take another one, and this will become ethers. Okay, it's coming from Hardhat. Okay, so these are the two packages we have. Okay, if I console log out the expect, you will see I'll get a function back. You can see this is the function we have, and we're going to use it to compare. Okay, and compare, and you will get that whether it's an error or it's a success. Okay, so that's how it works. Simply comment this out. Let's bring this down, and so in Hardhat we have a very special keyword called described. Okay, and it's coming from Mocha library. So we're going to do practically. Okay, but at the end I will show you that what are the ways you can write the script for the test using the Mocha library and chai library. Okay, so this is how we write the script. Okay, we'll take this describe keyword, and here we're going to define our contract name. You can define literally anything. Okay, And now we have to define the function name, but it's never gonna be an async function. Okay, we have to take a normal function. So let me tell you the plan I have for writing the script. So what I will do, I'm going to extract the code which I want to run over and over again and convert into a function. So whenever I will call any test, that code will run. Okay, so that's the simple abstraction I'm doing here. So what I will do, I will simply take this async function, and here I'm going to give the name of that function which I want to run over and over again. Okay, so here I'm going to call this suppose run every time. Okay, so this is the function, simple function, and whatever I'm going to write inside this, I want to run every single time whenever I want to test. Okay, and here I'm going to define all those variables. So first thing, I'll take this const, and here I'm going to define the year. Okay, because remember that our contract need time and value. Okay, so we're going to define the year in second. So we'll do the same thing, 65 multiplied by 60, and that's the time we got in second. Now we have to define the, let's say, amount. So here the amount we're going to pass into the terms of GUI. Okay, so 00, we have to add total 990. Okay, so that's what we have here. And now let me call this function. Okay, so this is the general way, and this is the general convention you have to follow. Okay, whenever you want to create any abstraction, there is a tons of way you can do, but this is the simplest way. And most of the code which are written, the test contracts are written in this format, and if you look at the documentation, you will find the exact way. Okay, so that's why I'm going with this approach. Now what I want to do, I want to simply console log out the values, and let me show you what we get. Okay, so we'll type 1 year in second, and we'll type 1 GUI. So let me open up the terminal and redeploy the contract, and here you can see we got the current timestamp, and we got the 1 year timestamp. So we got 1 year in second, and we got a current GUI. Okay, so that's the two data we have, and you can do something like this as well. Okay, right now you can see I have written in a normal way, but you can space it out. Okay, it will work exactly in the same way. Redeploy the contract, and you can see it's working exactly in the same way. So the output you will get, it will same. So that's how you can define the variables. And let me comment this out, and we have to take a couple of more variables. Okay, so let's come down, and we're going to take a variable by the name, let's say, locked amount, because we have to define that how much amount we want to lock. Okay, and we're going to use this 1 GUI. You can type it directly, but here I would like to take as a variable. Okay, so I'll take this const, and I will say unlock time. So we have to define the time as well. So we have the current timestamp. So for that, we're going to use a wait. We'll use this time. As you remember that we have this time object, in that we have couple of functions. So we have going to use this latest function. This will give us the latest timestamp. Okay, that's what we are calling here, and we're going to simply add the time which we have in 1 year advance. Okay, so that will give the lock time. Okay, that looks cool. Hope you guys are getting. Let's come out. Let me simply console log out, and let me show you what we get in return. So we have the unlock time, and we have this. Okay, simply deploy this one, and here you can see we got the time, we got the GUI, we got the lock time. Everything's working fine. Simply comment this out. Now here we're going to simply get all the accounts. Okay, so we'll take a variable, and here we're going to, so altogether Hardhat provide you 20 accounts. Okay, so I will take 2 accounts, one and another account. Okay, so this is the 2 account we are taking, and I will use this await ether.get signers. This will give us the accounts, and if I simply console log out that, so accounts, owner, and other accounts, you will see we are getting this. Okay, so here we got the 2 accounts. Okay, and in that we have all these data objects are available which we can use for different purposes. Okay, if you want to make a connection with a wallet, we can do that. Okay, so this is the 2 account we have. You can have multiple account. It's altogether provide you 20 account. Okay, so let me show you. Simply comment this out, and here you can import accounts like, let's say, account 1, account 2, account 3. So in this way you can go all the way to 20, because it will provide you 20 account, but we are only interested in 2. Simply open this, comment this one. Okay, I just wanted to show you, that's why I have written, and I'm not going to remove all this comment, because ultimately at the end I have to provide you this code. Now let's come here. We have the accounts. Now we're going to take this my test, because now we're going to actually interact with the contract, and we'll deploy. Okay, so we'll say update await. We're going to call this ether package get contract factory, and in that we have to pass the contract name. Same thing we have to do, await my contract deploy, and in that we have to pass the time and the amount. So we have the time, unlock time, and we're going to pass the value, and the value is going to be lock amount. That's the simple thing which we have follow in the deploy script, and the same thing we have to follow here. Okay, so that's looking pretty good. Now we have to simply come here and simply return this value. Okay, so all the data which we want to use in our different functions, that's all data we're going to return from this side, so we can use in later test function. Okay, because this code will run, this function will run every time whenever we test. Okay, so we want to return the entire instant of the contract, then we want to return the lock time, we want to return the lock amount, honor, and we want to return the other account. So these are the 5 data we are returning from this function. Okay, so simply come here, let me console log out all of these, and you will find that we are getting nothing here. Okay, if come here, if we reload that, and you can see it will become pass, and boom, everything is working fine. Okay, so we have successfully passed and this code is running fine. Okay, so this looking absolutely fine, so simply looking great. Okay, and now we're going to write the function which tests the contract. So we have variables, we have functions. So first we'll start with the variable, because at the time of deployment we are checking and updating our lock time, we are updating the amount in the contract. Okay, so first we have to check that whether we are successfully updating or not. Okay, so again we're going to follow the same convention, we have to use this describe. Okay, so when you describe this, use this describe block, what it does, it will allow you to check a specific condition which you want to take in a smart contract. Okay, and here we have to provide the name. So here I'm going to type this message, I'll say deployment, because I have to check all the datas at the time of deployment, and it will take a normal function. Okay, it will never take a async function, it will take normal function always. And here we're going to define we're going to simply check unlock time. Okay, and we have to get this data. So this is how we build the blocks. So we're going to use this it, and again this it is coming from the Mocha library. Okay, should check unlock time. Here we're going to use this async function, and that's the function we have. And now we can simply going to import the data. Okay, so we have my test and we have unlock time, which we have simply exported from the main core function. Okay, and that's coming from here. Okay, remember load fixture, and that we're going to pass the function name. Okay, so remember we have imported this load fixture at the top, because this load fixture allow us to run the function over and over again. Okay, and we are simply passing this. Okay, passing the function name, and this will give us the data. Okay, now let's come here, and to check this, let's simply test this one. Things are looking fine, and here you can see we got an error. It says that okay, somewhere I did my spelling mistake. Okay, so not a big deal, I can easily figure out. I hope you guys have noticed this spelling mistake. If you haven't, actually I was stuck for a while and I was stopped recording. Maybe at that point of time I made a spelling mistake. Okay, here is the problem. So simply remove this one, and I have to type the actual unlock time. So unlock time, and now it will work fine. Simply deploy the contract, and here you can see it's looking absolutely beautiful. We have deploy, things are looking pretty good. Or simply comment this out. Okay, as you can see, all the console log we done previously, that's all working here fine. Okay, things are looking pretty good. We are passed. Okay, so we have passed, and now we're going to check for the condition. Okay, so we're going to use this console dot, and I'm going to call this unlock time and my test. Simply clear the terminal and deploy the contract, and you can see boom, it's looked pretty good. Here you can see we have the lock time, and things are looking pretty good. Okay, all the data we are getting, all the instanced we are getting of the contract. Simply comment this out, and now actually we're going to compare it. So we have used this expect, this coming from the library. Okay, child library, and we're going to call our contract, because in that we have this function unlock time. Okay, make sure so there we have made this public, so we can easily able to call the function. Okay, and now we're going to say to equal, and what we are compared to, we want to compare with the unlock time. Okay, simply pass that. Okay, we have taken this data here, and we are importing this data unlock time, and we're going to simply pass it here. Okay, that's the simple comparison we are doing. Let me repeat what we are doing. We are using the except, that's coming from the child library. We are awaiting because it's a async function. We are using our contract name my test because it has all the instances of the contract, and our unlock time, as because we have made it public in our contract, so we have a getter function, so we are calling that, and we are trying to compare with the actual time. Okay, the time we have taken at the top in future. Okay, 1 year in future. So hope this makes sense to all of you, and this looks pretty good to me. Now that looks good. Let's test this one, and boom, you can see it looks pretty fine, and we have successfully passed the first stage. That means that the time we have provided, that's in the future 1 year. Okay, so that's absolutely looking fine. Okay, so let me comment this out and let me show you what the value you will get. Okay, so let me save it and let me console log out this as well. And if I deploy this one, and boom, here you can see, so you will get back an object, and in that you will have all this data. You can see this is the timestamp we have exactly in 1 year future. Okay, the message is undefined because we haven't defined anything. We have a log size, you don't need to worry about that, but the only thing you have to focus is in the big number, which is 1 year in, and that's looking absolutely fine. Okay, that looks pretty good, working pretty fine. Let me comment this because I don't want to show you that. I will just console log out for you guys that you can check the value. Now let's continue further. So this is the first check we have. Now let's write the second block. Okay, here we go to check for the owner. So the owner who deployed the contract and who is so here we have to check the owner. So we'll check that it should set the right owner. So the one who is deploying the contract, he has to be the owner of the contract. Here we're going to call this async function. Okay, and here we're going to simply import the data. So we need the contract instance, we need the owner. Okay, and that's coming from the same fixed loader. We have to call this function run every time. Okay, and now we're going to use the child library except, and we're going to simply compare it out. So it's a similar thing we have to do over and over again. Await, we have to take the contract owner. Again, we are you calling this owner function because it's a public. So we have a getter function, will to equal, and we're going to pass the owner dot address. Okay, so this owner has the all, so this owner contain all the properties of a single owner, like a address, network ID, host, everything. So we are trying to access the address only. Okay, so that looks pretty good. Now simply try to deploy this one, and let's try to have a look. And boom, here you can see both the test is successful. So we have successfully set the owner, our owner is right. Okay, that looks pretty good. So this is the second test we have, and let's write the third test and checking the balance. Okay, because we are sending some amount into our contract, so we have to test that as well. So we're going to follow the same convention. It will say should receive and store the fund to my test contract, and it's going to be async function, and we're going to import couple of things that's come in the contract itself and lock amount, and that's coming from loader fixture runtime. And here we're going to simply do the comparison. So we're going to console log out first thing, the amount. If I deploy that, test that, and here you can see this is the exact amount we have. Okay, now let's come down here and let's try to get the address account balance from the contract. Okay, so we'll say current balance, await ether dot provider dot get balance, and in this I'm going to provide the account address, and the account address I have of the contract in this my test address. Okay, so here I'm taking the contract address and try to find out that what amount I have inside the contract. Okay, so I'll simply do this console.log and contract balance, and I have to convert that into a number because it will come in the form of big number. So I will use this number to call function, and now let's have a look. If I test this, and boom, you can see I got the exact amount, looking perfect. Okay, so that's look perfect, and I just wanted, and that's for only showing you guys. Okay, simply comment this out. Okay, that looks fine. Comment this out, and now we're going to simply compare it. Okay, so we're going to use that wait, take the ether provider dot get balance and my test address, and we have to compare it to the equal, and in that we have to pass the lock amount. Okay, so this is the simple comparison we are doing with the contract balance to the amount we have taken as a variable. Okay, so that looks pretty good. Let's deploy that, test that, and boom, we have passed all the three tests. Okay, that looks pretty good. I hope you guys are getting excited and you are learning, guys. Okay, because it seems like we are repeating the same code, but here we are building up the logic. Okay, so it's always very important that you have to find out that all the possible way you can test the smart contract, and that's what you guys going to do exactly in the industry. Okay, so these are the three tests. This looks fine. Now let's come down. Now we're going to take one more test. So this time is condition check. Okay, so you have noticed one thing, that when we are deploying the contract, and that time we are checking for a condition. So what we are checking, we are checking that the time users should provide, it should be in future. Okay, 1 year in future. Okay, so we have to check that as well. Okay, we have to check that as well. You can do in one function, but I don't want to do that. I want to create a separate function for each condition checking. Okay, so same logic I have to follow here as well. So if I come back to my contract, here you can see, so here we have all these condition. Okay, so this is the condition we have in the constructor, and that's what we have to check. Okay, we have condition in the withdrawal, so we have to do the check for that as well. So let's come here and we'll say they take this, it should fail if the unlock is not in the future. Okay, so if the time the user is providing, if it's not in the future, then we have to throw the inner. Okay, so async function, and here you will find something very interesting. Let me show you. Let me write. Okay, so I will simply, what I'm going to do is I'm going to simply import the data. So I will take this. So what I'm going to do, I'm take this variable latest time, and this latest time is coming from the time. Here we have this time. Okay, we're going to use this library and we're going to call this latest. Okay, so this will give the latest timestamp. If I do the console log, and if I simply convert it to this, so if I test this, I will get the date. Okay, this is the time. It's a 321 days. Okay, so it's in the future. It's working fine. Okay, so hope this makes sense to all of you guys. We have the time in the future. Now we're going to take a variable called my contract, and this time I'm not going to import from the load fixture. Okay, I'm going to do it directly here. Okay, you have the both option. Okay, so let's do it directly. So here what I will do, I'll come here and I'm going to use this await ether package get contract factory. In that we have to pass the contract. Okay, now we have to simply take another variable and we're gonna call it, let's say, await. So we can do it directly test. Okay, except we're going to say await except deploy. We have to call it deploy, and in that we have to pass the data. So what we have to pass, we have to pass the latest time and we have to pass the value. Okay, so the amount we have is 1, and we're going to simply compare it out to be reverted with. Okay, so this is, again, I'm not coming up with, it's a part of the Mocha library. Okay, so what we are using here, that's a general convention. And if anything, if the time is not in the future, then this revert with will throw an error. Okay, and here we have to provide the same error message, unlock time should be in future. Okay, so you can see this is the exact message we have given in our smart contract, and the same message we have to provide here. Okay, the same message. If you don't do that, you will get an error. Let me show you. So you can see everything is looking fine. We are successfully comparing, and now we can simply test this out. Okay, so let's come here and let's try to test. You can see the test and it's been successful. All the 4 tests are looking fine. So you can see things are looking good. And now what I want to do is, things are looking good here. You can see this is what we have, this is what we have. Okay, and that's what we have given here. Okay, that's what we are checking here, the time in future. So let's come here in the script, and here you can see this is what we have. Okay, and that's what we are passing, and same thing we are doing here as well. So let's bring this terminal down. Things are looking good. This one is also fine. Now what we can do, let's close it. Okay, not open this one. We have to close this describe block, deploy one, and let's create another describe block. Okay, so that's all the check we have done so far. That's for the deployment. Okay, let me come here and let's take another describe block. This time we'll say withdrawal. Okay, because we have to check for that. So we'll say withdrawals. Okay, function, normal function, and in that we're going to simply use this another describe block, and in this time we're going to call validate. Okay, because in the withdrawal function we are validating certain data. Okay, so that's why I'm taking this another describe blocks function, and in that First thing, we're going to check for the withdrawal timestamp. Okay, so we allow only the owner to withdraw when the time is in the future and after 1 year. Okay, so we'll take this. It should revert with the right if called too soon. Okay, so if the owner try to withdraw the fund without the time period is getting over early, then we have to throw the right error message, because that's the check we are doing in our smart contract. Okay, so it's going to be async function, and we have to simply import the data. So we need to take this my test, and that's coming from loader fixture. Okay, so we have the my test instead of the contract. Now we can simply await, and we're going to compare it. Okay, so we'll take this my test, and we have this withdrawal function in that. Okay, so we have the withdrawal function. Let's come here, and this is the spelling we have provided. Simply copy and simply paste here. Okay, so we have the withdrawal function, and we go to, and this time we'll say to be rewarded with. Okay, so because we have to throw an error message, and that's what we have done above in the previous function. Okay, and in that we have to pass the error message. Okay, so let's come here, and here you can see this is the error message we are passing. Wait till the time period is completed. Okay, so make sure whatever error message you are passing here, you have to provide the same error message there, otherwise it will throw an error. If it's in capital, you have to provide it in capital. Okay, so what I will do, I will simply come here, and I'm going to simply copy this one, and come back and simply paste here. Okay, and now we can simply test this out. So let's deploy and went through. Okay, you can see withdraw validations, and that looks pretty good. Okay, if I change this to small, I will get an error. If I test this one, and boom, here you can see I got an error. It says expected transaction to be rewarded with the reason wait till the time period is completed, but it's actually needed wait till the time is period with W. Okay, capital W. So make sure you always write the exact message whatever you have given in the contract, and the same in the deploy script. Okay, if you do it the right way, it will not throw an error, and the test is passed. Okay, so that looks pretty good. That's the first validation block we have for testing the contract. Let's write the another one. We have to sing in validation. We have to revert the message for right owner. Okay, so if someone else tried to withdraw the fund from the contract, so we have to display the message for that, because that's the condition check we are doing in the withdrawal function as well. Okay, so we'll say async function, and we need to have the instant of the contract. So we'll take a const and test my. We need the lock time, and we need the another account, because that's the account we're going to use for withdrawing the fund, and this will throw an error. Okay, and that's coming from the same fixture loader. Okay, runtime, and this one is const, not console. So that's the instances we have. Okay, now what I want, new time. Okay, so I will take another time. I'll say await time increase and unlock time. So what this will do, it will check for that the time we have provided, it's in the future or not. Okay, it's in the future, so that's what it will check. So I just simply want to console log out this time, new time, and you can see, just wait, and here we can get undefined, because this function is a condition. Okay, it will check for a condition. It will not return any value. It will only check whatever time you have provided and when the function is getting called. If both the times are same, then it will throw an error, but it will always look for the future time. Okay, so that will increase the time in future, whatever time you have provided. Okay, so that's the simple condition we have. Okay, so that's the condition we have here. Now we can simply comment this, because we don't need it. We can simply without call this function without storing in a variable. I just wanted to show you that this is what you get when you try to access the value. You get undefined. Okay, so we'll say time increase to, and we have to pass the lock time. Okay, so it will check for the future. Again, it's in the Mocha library. It's just like a condition checking. Okay, so we have that one, and now we're going to simply compare it. So except we'll take the contract instant, and we're going to call this connect, which we have available in the method, and we're going to simply try to connect with the different account. Okay, different account, and here we're going to say withdrawal function to be rewarded. Okay, rewarded with, and we have to pass the exact message, simply you are not an owner. First here. Okay, so let me explain what I'm doing here. First, I'm using this time increase function, which will check for the condition that whatever time we have provided, it's above that. Okay, so that's the condition check will happen, and then we are comparing it. Okay, so we are trying to call this withdrawal function with the help of a connect method which we have in our contract instant and with the other account. Okay, so try to withdraw the fund, so we want to throw this error message. Okay, things are making sense to all of you guys, and now let's try to test this out. So, and boom, you can see all the tests we got passed. So we have to do this two validation, it's working fine, looking perfect, absolutely. Now let's comment this, let's try the third condition. So we have to check for the not fail if the unlock time has arrived and the owner calls it. So now what I want to check, suppose just imagine that I'm calling this function right now, and at the same time the lock time is getting over. Okay, so both the things happening in the same time. Okay, so in such scenario I want to throw the error and I don't allow the owner to do the transactions. I want the time should be in future, not exact time. Okay, you can allow, but I don't want to have it, I just want to have in future, not at the exact time. Okay, again async function, and we're going to call this one, let's say we'll take this const my test unlock time await, and we have to load the data. And now we're going to simply use this time increase because we have to check the time, but it's in the future, and increase, and we'll call this await, and we're going to simply compare the withdrawal function. Okay, not to be, okay, reverted. Okay, so that's the check we have to do. Okay, so in this, whenever this happens, we have to simply stop the transaction, we don't need to do the transaction. Okay, that's simple checks we are doing. Hope these things are making sense to all of you. We are not doing anything unusual. If you guys are a regular follower of my channel, these are the pretty basic things. Okay, I do understand that you guys are doing this harder testing for the very first time, but these are not so technical. Okay, so that's what we have here. Let's close this one and let's try to test this out. And boom, here you can see all the 7 tests we have passed, looking pretty good now. So this is the absolutely great. And I remember that we have events and we have transfer as well. Okay, so let's check for the events. Okay, so again we have to describe the block, and we'll say event, it will take a normal functions, and we have to submit that. Now we have to check for the event. So whenever someone do the transfer or withdraw the fund, so whenever the owner will withdraw the fund, we have to do the check for that whether we are successfully creating the event or not. Okay, so we have to give the message should emit the event on withdrawal. Okay, we have to take this async functions, and we need the data. Okay, so it's coming we need the contract, we need the unlock time, we need the lock amount, and it's coming from the fixture loader. Nothing new, we are doing following the same old school. Come down, we have to take this await, time should be in future, increase to, and the time. Now we have to simply compare it. We have the contract, in that contract we have this withdrawal function. Okay, we're going to call it, and we're going to compare it to equal to emit. Okay, not equal, emit, sorry, because we are trying to, because this is an event check. Okay, and in that we have to pass the data, so my test, and we have to pass this is, okay, you can see this is the event name we have given, and we have to simply pass this name, simply copy and paste here. So that's the event name we have, and we have to simply compare it out. Okay, so with rug we have imported from the library, and that's what we're going to call it, amount, and we have to pass the value. Okay, and that's for the event check. Okay, so that's looking absolutely pretty fine. Now let's try to check it out. Okay, so that looks pretty good. Let's do the test, and boom, that looks pretty good. So all the 8 tests we have passed successfully. Okay, simple, not complicated. And let's bring this out, and we have to write one more block. Okay, so we have to check for one more conditions, and this is going to be the final one. So this time we have to check for the transfer, because at the end we are transferring the fund from one account to the other. Okay, from the user to the from the contract to the user. Okay, so we'll say describe, we'll say transfer, normal function, and we have to simply write this it block. So we'll say should transfer the fund to the owner, async function. Okay, now we're going to simply import the contract and lock time and lock amount and owner itself, and that's coming from load fixture. Okay, so we have this instances. Now we have to do the check again, we have to check for the future. Okay, increase, and now we have to simply do the comparison events. We'll take the contract, in that we have the withdrawal function, we're going to check ether balance, okay, because we are looking for the change, and in that we have to simply pass the honor. This is going to be the might a contract, okay, and here we will take the lock amount minus lock amount, okay. That's the simple thing we are doing for the transfer check. So this pretty look good. Make sure to wrap this in a bracket as a form of array. So that looks pretty good. Hope these things are making sense to all of you guys, okay. That's a pretty simple things we are doing here. Now let's try to test this one, and boom, here we have successfully tested all the 9 tests, okay. So that looks pretty good. That looks pretty intensive. Hope these things are making sense to all of you guys, okay. So we have written huge line of codes, we have different blocks, okay. So this smart contract is pretty small, but you have seen that we have written huge code for the testing purpose, okay, because it's very important that you have to find out all the possible way to test every single value, okay. So that looks pretty good. And now close this one and close this describe block, okay. So that's looks pretty good. Everything's are in place. We have this development, withdrawal, event, transfer, all the functions are looking good, okay. And that's the only thing I want to cover about the smart contract testing in Hardhat and in this crash course. So if you guys have understood all of these, whatever we have covered, whatever the function we are calling, the way we are building the logic for testing the smart contract, if you guys really have understood all of these things, then you can easily able to test any kind of contract, no matter how big the contract is. Right now you know that how to check the value and what are the value you have to check, how to check the state variable, how to check the constructor, how to check the conditions, how to check the transfer. So you guys have got the clear picture that what are the testing you have to do, on which variable you have to do, and how to do it, okay. So I'll try my best to complete this as simple as possible, but don't need to worry about it. This is a simple crash code, but as we are already working on our Solidity course, and in that we are building a smart contract, so we're going to use this testing a lot, okay, because in that course we're going to have a lot of huge contract, okay, like hotel management, we have hotel management contract, will have hotel booking contract, will have. So we're going to do all the testing in that, okay. So don't need to worry about. If you still confused, watch one more time, try to understand everything, and then you can continue and start testing different type of contract, which you will do in the Solidity program, okay. So hope this entire video makes sense to all of you and you guys have enjoyed and learned something new. If you really do so, do hit like and subscribe, and do leave your thoughts in the comment section that what you guys think and what kind of project we can build, what ideas you have. I'll try to build a community where we can help each other. If you guys really have a good project idea, you can just pitch me. We'll try to work together to build a project on that, okay. So hope to see you in the next video, and that's the only thing I want to cover. And if you're new to my channel, hit like and subscribe, and that will motivate me. And if you haven't watched the project which we have already built, like NFT marketplace, like ERC20 tokens, so make sure to watch that. That will give you a very good idea about the contract development and Web3 space, okay. So hope to see you in the next video. Have a wonderful day. For the time being, take care.